how's everyone doing this morning? Is everyone sufficiently caffeinated? Yes, okay, good. Is there anyone over-caffeinated, or is it too early for that? Okay, one per. Well, you're dealing with technology, so that's probably a good thing. All right, how are we doing? We're good to go? Okay. Okay, people in the room can hear me, people online can hear me. Yes, yes. Okay, great. So you heard a little bit about James right now, giving a very high-level overview of the possible future of programming and the law. And I'm going to drill into one of the particular things that he talked about, which is this notion of legal calculi, or like generalizing PL ideas across different legal programming projects. Before I dive in, I'm going to give you all my standard disclaimer for this kind of talk. Okay? I'm not a lawyer. I don't play one on TV. This presentation does not constitute legal advice. Okay? If you do have legal questions, there are probably actual lawyers in the room that you can go to. The second disclaimer is that this talk is meant to be more sort of a call to arms, and it may end up leaving you with more questions than answers. And if that happens, that's actually a good thing. Okay? All right, so let's start with a tale of two legal programming languages that we've heard a little bit about so far, Orlando and CATALA. Orlando is some work that I've been doing with James, Nate Foster, and some other collaborators at Cornell University. And it's a little language for talking about property law. And this is what programs in Orlando look like, right? So you can start talking about like ownership of certain pieces of property. And then you can talk about how that ownership is supposed to change in accordance with events that happen in the world. And then you can sort of write down those events and see how that ownership changes over time. Okay? So this is, in fact, an actual Orlando program. It looks like English, but you can type this into our implementation and it will work. Okay, so what happens when you do this? Well, under the covers, this gets translated into a data structure, or rather a sort of intermediate program that looks like this, right? Whereas we've taken the English language that we've actually written, English in quotations, that we've written down, and we've turned this into this sort of pseudocode, where individual parts in the English language program have been turned into particular clauses or phrases, right? They've been connected up using what I have here is the semicolon, so kind of sequential composition. But we've also done some things like adding in new components, like the atom olive all the way on the right-hand side, that weren't there in the English version that we have, but is sort of essential when you try to do legal reasoning about this, okay? So we've done this kind of desugaring pass, but this pass isn't trivial. There are some things that we do that may not be obvious at first glance, right? And we've also done things like introduce, like turn conditions that were in English language into sort of computational conditions, right? So in English, we talk about, Alice for life and until Bob marries, and we've turned that into the conditionals that you see attached to the while nodes. And this is what James was talking about when he was talking about the border between PL and law and AI and law, right? Like these conditions, you can think of them as sort of escape hatches where you can plug in more advanced reasoning if you need to, okay? So this is how this desugaring happens. And once you've desugared into this intermediate stage, you can then plug in semantics, right? We can give meaning to these programs, and we can talk about what happens when you plug in more pieces, right? So when an event happens, say Alice dies, our semantics then say, okay, we should look at the conditions in our program that talk about Alice being alive, and then we should do something about them, right? What is that something? That something is informed by what would happen if you were thinking about this from a property law standpoint, right? So in this case, the conditions of Alice alive would turn false, and that means we now need to sort of prune and rearrange the clauses that were affected, okay? Similarly, we can keep on going. We can add another conveyance that sort of changes this tree in another way. We can add another condition that's going to change it in another way, and so on and so forth. Okay? So I don't want to talk into the nitty-gritty details of everything that's going on, but at a high level, I just want to provide this idea, right? The reason we can do all this computing and changing things is that we've come up with something that we're calling a legal calculus, right? This is what I've written down on the right-hand side, and that's sort of the guts of Orlando, right? It's this really small, minimal language, and we can compile a wide range of these sort of English-like statements into this very small language on the right, right? And once we've done that, that allows us to do a number of different things. So firstly, the features of these language are sort of just the set of things that we need to express the things that are interesting on the legal side, right? And as I talked about a couple slides ago, the compilation from the English language to this core minimal language is sort of non-trivial, right? Some of it is straightforward, but some of it has like little edge cases that are of legal importance that we need to take into account. Okay. But once we have this, it lets us do some interesting things. So firstly, programs in this little language itself are of interest. I've already shown you the kind of what we call the interest trees that are the programs in this language. I've shown you a little bit about how they can change in response to different actions and scenarios. And if you stick around for my collaborator's talk, which is in one of the afternoon sessions, we'll go into more detail about how these interest trees can be decorated with information that's interesting to legal professionals. So the programs that come into this language are themselves of interest. And they let us do interesting things. So in a paper we wrote a couple years ago that we presented at Onward 2019, we could use this formalism to prove things that we're calling legal theorems. So these are ideas about property law that property law practitioners have taken for granted for a long time. This is things like only one person should have ownership of a property over at any given time, right? And we've actually been able to come up with proofs for them based on the way we've devised our legal calculus. Now, another thing to notice is that this is not a standard computing model like a lambda calculus, right? If you're familiar with emph, you might notice that the structure of our calculus looks a little like a traditional imperative programming language. But if you dig into the semantics, the actual semantics of things like while or if are a little different than traditional languages. And in particular, a large part of that is to deal with how things work in the real world, where conditions can go back and forth between being true and false. Okay? So this is a formalism. It's a mini language that operates at a level that's slightly higher than sort of lambda calculus. Okay. So that was Orlando. The second language is CATALA, which has been made by some of the people in this room. And CATALA is made for expressing sort of rules or legislation that looks like this, right? So this is an example where someone is writing down the rules that governs, say, a graduate student stipend. And the interesting thing to note is that the way it's written, it's almost written with like a high-level guideline. That's number one, which lets you calculate sort of the base stipend that a student should receive. But then the remaining rules are sort of exceptions to the first rule, right? So the second one says, what should happen if the stipend is above a certain amount? And then the second one is, say, what should happen if the student is like a more senior student, right? So you have one base rule, and then you have a couple of exceptions to this rule, right? And CATALA actually lets you write this in sort of a more program-like form, right? Where each of the clauses that we saw in the previous slide, they turn into one of these CATALA scopes that basically tell you how to calculate something. And each subsequent scope lets you override any of the things that were calculated previously, right? So on the left here is what you would write in the CATALA surface syntax, and on the right is sort of the intermediate representation of CATALA. This is something that they call the default calculus, right? And the key thing to note here is that the default calculus is not just a simple desugaring of the stuff on the left, right? In particular, it does things like it realizes that this notion of the cap is actually defined in a number of different places, and there's an exception right at the bottom that sort of adds more interesting things to the definition, right? So in order to go from the left to the right, there has to be some non-trivial computation going on that sort of looks at all the scopes and collects information about what's happening to come up with the ultimate definition of the cap, okay? Again, I don't want this to be a deep dive into CATALA or Orlando. I just want you to get a general high-level idea of what's going on. Okay, so we can think about CATALA as sort of another legal calculus. In particular, this right-hand program that we have here, is in a language that's over there on the right. This is what they call their default calculus. And it sort of does a lot of the things that we saw happen in the Orlando case as well, right? It reduces a number of high-level forms to a smaller number of core constructs, right? Particular features in this core calculus, especially the part that says the default D over there, are used to express things that are of legal interest. In this case, this default calculus allows CATALA to express this sort of have a rule and then have exceptions to the rule form that we just saw in the example, right? And as we saw in the previous case, the compilation from the surface to this default calculus is non-trivial, right? Any compiler for this kind of has to do a bunch of interesting stuff that's not just desugaring syntax. And finally, in CATALA's case, this default calculus actually compiles down to an extended lambda calculus. But again, a lot of the interesting stuff is kind of happening at this middle level, right? This middle level captures both the interesting things of the legal domain, but also allows a simpler form of computation to happen because it stripped away all the unnecessary complexities, right? Okay, so what's happened so far? So far, we've looked at two very different programming languages for the law, and we've noticed that they have sort of this intermediate form that has a number of key commonalities, right? And the question we want to ask is, well, is this a general trend? Is this notion of having some kind of an interesting middle point something that we can talk of as happening in general as we talk more about legal programming languages, right? Can we go from the two that we talked about to sort of N, or in the general case? So to do that, it would be helpful to sort of think about what are the things that we just looked at, right? So what are properties of these things that we've called, that I've been calling a legal calculus or legal calculi? Well, at the core, they're the sweet spot between this kind of human-readable high-level language and a low-level target, right? In Orlando's case, the human-readable, the version is sort of very human-readable. It's like English pseudocode almost. And in CATALA's version, the low-level target is actually lambda calculus, which you can then compile down to any standard programming language. As we've been talking about, if you look at things sort of top-down, this legal calculus lets us reduce a large number of high-level constructs to a smaller number of core features, right? This legal calculus is much simpler than the kinds of programs that you can actually write down. And also, crucially, some of the features in these languages are tailored to be able to represent things that are interesting in the legal domain, right? And in order to do this, the compilation process has to be non-trivial, right? It's not just a simple syntactic desugaring. You either have to do some kind of a program analysis or do some things that are of legal interest but might be non-obvious from a computing perspective. Now, if we look at things sort of bottom up, the reason that having this sort of legal calculus sit at the middle level is because it retains a lot of the interesting properties of the legal domain, right? So for Orlando, we could prove these legal theorems because we were operating at a level that was sort of higher than lambda calculus, right? We still preserved enough of the legal formalism to be able to say interesting things about the legal domain that we were concerned with, right? And the argument that I want to make in this talk, and that hopefully you will agree with, is that these legal calculi are in and of themselves interesting objects of study, right? It's not just the fact that we can, compile property law to lambda calculus that's interesting. It's this idea that there's this middle ground that is interesting and is something we should focus on. Okay. So here are some open questions that we might want to think about going forward. James talked about the composing contracts work from 2009, something. It would be interesting to see that work through the lens of a legal calculus, for example, right? I've already talked a little bit about what features or properties legal calculi might have in common. It would be nice to sort of formalize them or have a more concrete set of them. Especially and from sort of the implementation side, can we build a common framework for legal calculi, right? I've only looked at two, but we're having this conference because more and more people are interested in applying PL ideas to legal calculi, to apply PL ideas to the law, and maybe this notion of the legal calculi might help us as a community build reusable tools and components that can help us do our work, right? And once we build these tools, we can maybe start looking at different front ends that can leverage them, different back ends, and sort of have a common toolkit to work with. And I want to leave with this idea of where do we look to for inspiration, right? We as a community, we're still pretty new, and it would be nice to have sort of a guiding light to look at. And as I was making this presentation, well, I thought about normal compilers, right? If you've built a normal compiler or have worked with compilers, a modern compiler sort of looks something like this, right? Where you have some front end that takes source code, you have some back end that turns, that emits machine code, but in the middle you have sort of some kind of an intermediate representation. And having that intermediate representation lets you do interesting things, right? And arguably, one of the most interesting and most successful compiler research projects of the last decade or so has been LLVM, right? Where they had this common instruction set architecture in the middle, and they managed to build a whole bunch of different front ends to it, a bunch of different back ends to it, and they've also been able to do a lot of interesting things like work on linkers, debuggers, optimization algorithms, and these days they're even reaching out to theorem provers to give you interesting properties. And so the high-level question that I want to leave all of us is, the high-level question is, can we build our own LLVM, right? Can we build this kind of standardized toolkit based around the notion of legal calculi for legal languages? Okay. So I will stop there, right on time. And if we have time, take questions.
Yep. So we have plenty of questions online. Are there any questions in the room? Yes.
So, kind of following on the previous talk by James, I'm curious about how these interact with parts of the law that aren't in these legal calculi. So in particular, I'm thinking about, say, a part of the contract gets struck down by a court.
Right.
Is it possible to compute what the new contract is, or is that something that's always going to have to be done by hand?
That's a good question. So I would say, based on my experience working in this area over the last few years, I think there is always going to be some sort of a human element involved, right? I don't think it's realistic for us to say we're going to be building 100% completely automated tools for this. However, I think we can formalize enough of that we can build sort of assistants that help do interesting things. Like in your example, if you had a formalized version of the contract, right, in terms of like modules or scopes or functions, you could maybe have the legal decision say, we're basically striking down this particular module of your contract. And then you could omit it or rewrite it or plug in something else. But I think we can get to the point where we can build automated tools that let you say, okay, this is the area where you need to make the change, and then it's up to you as the human to maybe figure out what that change should be. Yeah.
All right, thank you. We have two questions. We have many questions online, but unfortunately, we will have to take a break at some point, so let's pick two. The first one is from Denis. Would you envision a layered or orthogonal semantic architecture for the combination of legal calculi?
Both. I understand that's maybe an unsatisfying answer. I think, like as James hinted a bit about his talk, like there may be some aspects of the law which might be common across a variety of domains. Like, for example, I think CATALA's use of this default calculus where you have some kind of initial rule and then you have exceptions to that, that might be something that's common to a variety of pieces of legislation or areas of law, and I think like that would be something that could be common. Whereas I think if you're trying to say build a common platform that handles say both CATALA and Orlando, I can see there being areas where the two don't overlap very much or have like different things to say, and in that case, you would want something that's more modular where you can plug and play as needed.
All right, and last question from Giovanni. Question regarding Orlando. Is there any attempt to connect to other controlled natural languages, attempt to, or some GF resource? Do you think we should restart from scratch in each subfield of law or attempt to find an extensible core?
Yeah, so to answer the first part of that, we haven't connected Orlando to any other tools or utilities. We've sort of been pushing the natural language part into this escape hatch that I talked about at the beginning. To answer the second part, yeah, I think it would be great if we could build some common set of tools or some kind of common platform for us to host different kinds of legal law projects. Legal languages projects. That would be great, I think. Yeah.
All right, well, thanks very much. We will now take a 10-minute break. We will be resuming in 10 minutes. Thanks. Let's thank the speaker again. And for the questions that have not been answered, I encourage you to message the speaker on AirMeet so that you can have a long-winded discussion that goes on after this. Thanks again.
All right, thank you so much.